The Parkinson's podcast is brought to you by the Davis-Phinney Foundation and brings you the stories, wisdom, and expertise of people living with Parkinson's, care partners, and Parkinson's professionals. Additionally, we would like to thank our title podcast sponsor, AbbVie, for helping us bring this content to you. AbbVie is committed to recognizing the uniqueness and needs of each person living with Parkinson's and delivering innovative solutions for patients, care partners, and clinicians. In this episode, Dr. Anna Lembke, an internationally recognized expert in addiction and dopamine, discusses addiction, dopamine's role in pain and pleasure, dopamine agonists, and more.
So, we've been wired over millions of years of evolution to reflexively approach pleasure and avoid pain. It's what's kept us alive in a world of scarcity and ever-present danger, which is the world that we've lived in for most of humanity. And some of the very exciting findings in neuroscience in the past 75 years show that pain and pleasure are actually co-located in the brain. So what that means is that the same parts of the brain that process pleasure also process pain, and they work like opposite sides of a balance. So if you imagine that in this pleasure pain circuit, you have a beam on a central fulcrum, kind of like a teeter-totter in a kid's playground. That beam represents how we process pleasure and pain. Now, it's a crude and oversimplified representation, but it gets at the heart of some of the key aspects of this neural circuitry, especially as relates to the development of the problem of addiction. And essentially, it works like this. When we experience pleasure, the balance tips one way. When we experience pain, it tips the other. But there are certain overarching rules governing this balance. And the first and most important one is that the balance wants to remain level. And with any deviation from neutrality, our brains will work very hard to restore a level balance, or what neuroscientists call homeostasis. So, for example, let's say we ingest some kind of intoxicant. It can be a mild intoxicant, alcohol, nicotine, or whatever, caffeine, romance novels, Netflix, Instagram, YouTube, you name it. What we get is a little release of dopamine in that specific reward circuitry. So this is a different circuitry than is involved in Parkinson's disease. And our pleasure-pain balance tips to the side of pleasure. But no sooner has that happened than our brain will adapt to that slight bump in dopamine by downregulating our own dopamine transmission and production in that circuitry. And that's what's called neuroadaptation. I like to imagine that as these little neuroadaptation gremlins hopping on the pain side of the balance to bring it level again. But the thing about the gremlins is they really like it on the balance. So they don't get off as soon as the balance is level. They stay on until it's tilted an equal and opposite amount to the side of pain. And that's what's called the come down, the opponent process mechanism, the hangover, the after effect, that moment of wanting to watch one more TikTok or eat one more cookie. Now, if we wait long enough, those gremlins hop off and homeostasis, or a level balance, is restored. But the key lesson here is that our pleasure comes at a cost, and the cost is the pain afterwards. And that is how we restore a homeostasis or a level balance. We have to pay for it. If we don't pay for it beforehand, we pay for it afterwards. And this is really key to understanding addiction, because the second rule of the balance is that with repeated exposure to the same or similar dopamine releasing substance or behavior, the brain accommodates and adapts. Those neurons begin to multiply and get bigger and stronger. And that initial deviation to pleasure gets weaker and shorter, but that after response to pain gets stronger and longer. In other words, we start to accumulate more and more gremlins on the pain side of the balance until we have enough to fill this whole room. And now we are essentially entering addicted brain, where we're walking around with a balance that's deviated to the side of pain unless we ingest more and more of our intoxicant. But the more we ingest, the more gremlins we make. So it's really a losing battle with the gremlins. And ultimately, we end up with the gremlins permanently parked out on the pain side of the balance, Okay. And then we need to use our drug not to get high, but just to level the balance and feel normal. And when we're not using, the balance is tilted to the side of pain, and we're experiencing the universal symptoms of withdrawal from any addictive substance, which are anxiety, irritability, insomnia, depression, and craving. I think the way to think about it is that you're essentially changing your hedonic or your joy set point. Theoretically, we all start out with a level balance, and that may not, in fact, be true, right? Some people start out maybe with a balance tilted to the side of pain, people who are depressed, people who struggle with other types of pain syndromes. But let's presume, for the sake of keeping it simple, we start out with a level balance. We have a certain suppleness, a certain, responsiveness. We ingest something that's pleasurable. We release dopamine in the reward pathway. We tilt the side of pleasure. The gremlins hop onto the pain side. We have a little bit of that urge, to have another cookie. But the interesting thing is we want to have another cookie even while we're eating the first cookie, because it's the directionality of the dopamine that makes a difference. So we get a dopamine release. It's tilting this direction, pleasure. The gremlins hop on here. And then even though I'm net on the pleasure side, I'm tilting toward the pain side. I want another cookie. I'm not even done with the first cookie. I want another cookie. And then I go to the pain side, and then it's really much more painful. Then I wait and the gremlins hop off. But with repeated exposure, I get more and more gremlins, and then I reset my threshold for experiencing pleasure and pain. Now I need a whole lot more pleasure to get any pleasure at all. And when I'm not using, I'm in pain. So then I'm much more sensitive to pain, and I'm walking around in pain. And this is why people relapse even, long after they've stopped using their drug of choice. It's because they've potentially lost the neuroplasticity to, reset reward pathways. So we think that with enough neuroplasticity, if we stop the drug, eventually those neuroadaptation gremlins hop off. We start to upregulate more of our dopamine, increase our dopamine receptors, and eventually we're back to homeostasis. But we do believe that some people, even with very extended amounts of abstinence from their drug, have essentially broken their pleasure-pain balance. So for example, that's why we use things like methadone maintenance, which is an opioid, to treat opioid use disorder. It's because we see some patients with severe opioid addiction, they end up, changing their hedonic set point. But even with sustained abstinence, their balance won't go back to a level position. So now we're giving them opioids on this side, not because it gets them high. It just restores homeostasis enough so that they can, not be constantly focused on getting their next fix, and they can actually, engage in their families and their work and recovery work. Well, we are reflexively engineered over millions of years of evolution to approach pleasure and avoid pain. And that's absolutely fundamental to even the smallest child who burns their finger on a stove will remember pre-verbally not to touch that stove again. It's deeply ingrained. It's conserved over millions of years of evolution and across species. And the reason for that is because for most of humanity, we have lived in a world of extreme scarcity and ever-present danger, where in order to survive, we need to constantly be motivated to get the next food, clothing, shelter, mate, just to barely make it to age 30, right? And we also were exposed to incredible elements. So we lived with almost constant pain, but we needed to make sure that that pain also abated, right? So not only is pleasure transitory, but this system also makes sure that pain is transitory. If the initial insult is a painful stimulus, those neuroadaptation gremlins hop on the pleasure side of the balance, and we start to upregulate our own endogenous opioids, the opioids that we make, our own endogenous dopamine, our endogenous cannabinoids, right? We get the signal, oh, whoops, there's been an injury, start to make those feel-good hormones and neurotransmitters. Thank goodness, right? Otherwise, we would be constantly writhing in agony. So this wiring was adapted for a world of a lot of pain and very few pleasures. We now live in a world that's essentially the opposite. Infinite, highly potent pleasures and not a lot of pain. We're largely insulated from pain. And this is the problem. It's the mismatch between our primitive wiring and the modern ecosystem that's leading to so much unhappiness. In my 25 years of psychiatric practice, I have seen increasing numbers of patients coming in who have really great lives on the face of it, right? They have had lovely parents, no significant trauma. They have plenty of money. They have the best education that money can buy. They have friends, you name it, but they're deeply unhappy, unmotivated, can't sleep. And really the stressor here, in my opinion, is the stress of overabundance and the ways in which we as individuals and as societies are slowly shifting our pleasure-pain balance to the side of pain, changing our hedonic set point, because our brain is trying to accommodate the fire hose of dopamine that we're getting from everything from our, touching our smartphone in the morning to that first hit of coffee, to the rich foods that we eat through the day, to the Netflix binge at night. It's all basically overstimulating this particular circuit.
Yeah. So it's almost a curiosity how we're not in worse shape. I mean, when I think about everything that we're hit with every single day, it's like, is there anybody who's at that place where it's just like they have the right amount of pleasure? They have the right amount that hasn't gone too crazy, right?
Well, let me just say it's very hard to find that balance. But my point is it's gotten that much harder,
sure.
Paradoxically, that much harder because of overabundance. I mean, I think, again, if the initial stimulus is pain, then those gremlins hop on the pleasure side and we start to upregulate our own dopamine. So we can get our dopamine indirectly by paying for it up front, which is potentially a better way because it's more less vulnerable to this problem of, the dopamine deficit state, which is the state of being addicted and also being really unhappy. Right. So that's why I recommend things like exercise, ice cold water, all kinds of mind body work, things like meditation and prayer, anything that requires effortful engagement over a long period of time. This is all based on a body of work called hormesis. And hormesis is Greek for to set in motion. And basically it's the science of how when organisms are exposed to mild to moderate amounts of noxious stimuli, they essentially, it's good for them, right? So if it's too much of a noxious stimulus, it's lethal for the organism or it's harmful. But if you can just get that sweet spot where you get those gremlins to hop on the pleasure side and upregulate, your own feel-good hormones, you can find that, but you don't want to overdo it. So let me just start by clarifying that, dopamine, that Parkinson's is characterized by a depletion of dopamine in the substantia nigra, which is a separate area in the brain from this reward circuit that we've been talking about that's related to the disease of addiction and this pleasure-pain balance, which consists of the nucleus accumbens, the ventral tegmental area, and the prefrontal cortex. So these are distinct and separate circuits and regions. And the depletion of dopamine in the substantia nigra in Parkinson's is not characterized by a similar depletion of dopamine in the reward pathway. So those are separate and unrelated phenomena. They can co-occur, just like someone with Parkinson's could develop addiction, and someone with addiction could develop Parkinson's. But as far as we know, they're not. There's no like a causative influence there, or even a particularly noticeable correlation. It's not, for example, Parkinson's, as far as we know, is not a risk factor for addiction, unlike something like attention deficit disorder, which is, a cognitive processing prefrontal executive function disorder that is associated with addiction. So if I were to give you a spoonful of dopamine, it would do absolutely nothing to you because it doesn't cross the blood-brain barrier. But if I were to give you a dopamine precursor like L-Dopa or any of the dopamine precursors that are used to treat Parkinson's disease, it would cross the blood-brain barrier. It would affect your Parkinson's by augmenting dopamine in that region, but it would also affect your reward circuit. And the way that it affects the reward circuit is that it looks very much like, for some individuals, it's not a one-to-one, but it looks like it does increase the risk of developing addictive and impulse control disorders. So, for example, there's a very clear increase in people developing things like gambling addiction or shopping addiction who are being treated for Parkinson's with dopamine precursors. Importantly, dose and duration matter. So the longer they're on that medication and the higher the dose, the more likely they are to develop some kind of addictive picture related to that medication. Also, really importantly, when that medication is removed, let's say a gambling disorder emerges, and it's thought to be related to the dopamine precursor, and then that medication is stopped, typically that gambling disorder disappears. So there really seems to be a very clear relationship between the treatment using a dopamine precursor and the development of these types of addictive patterns. And there have been studies of whether or not you're using it for Parkinson's or, like, let's say, restless leg syndrome. It doesn't seem to matter. The key variable seems to be the medication or the dopamine precursor itself manifesting as, essentially hitting on that pleasure side of the balance, causing those gremlins to create that cycle and getting people into that vortex of compulsive overuse in their drive to restore baseline homeostasis in that reward circuit. The way that we define addiction is the continued compulsive use of a substance or behavior despite harm to self and or others. The way that we kind of categorize the criteria in the DSM-5, which is the Diagnostic and Statistical Manual of Mental Disorders, is by talking about the 4 C's and the WTF. So the 4 C's is control, compulsions, cravings, and consequences. So out of control use, where you find you went on a site to buy something at Amazon, and 2 hours later, you're still there spending money. Compulsions is a lot of mental real estate focused on getting the drug, using the drug, maybe hiding the drug use, as well as a certain level of automaticity, finding ourselves having the drug or engaging with the drug, even though we didn't really plan on it. So that's control, compulsions. Cravings is intense psychological and sometimes physical need for the drug that can come out of the blue. And then finally, consequences, especially continued use despite consequences, is really the hallmark of a severe addiction where people recognize, oh my goodness, I've now spent all of my savings or half of my savings because I'm doing online sports betting, but I still can't stop myself, right? So that's really the hallmark. Then you have the WTF. So W refers to withdrawal. This is where when I try to cut back or stop my drug, whether it's a substance like alcohol or a behavior like gambling or food, I find that I'm experiencing intense discomfort or withdrawal. That's those gremlins jumping up and down on the pain side of the balance. The T stands for tolerance. Tolerance also relates to neuroadaptation in those gremlins. It's where I need more of my drug in more potent forms over time in order to get the same effect. And then the F just stands for the F, just a way to remember it. So those are the things to look for. The other thing that's not in the DSM, but I think is very helpful, is if we find that we're lying about our use, whether we're lying about what we're consuming and putting into our bodies, or we're lying about how we're spending our time, especially on the internet. That should be a real red flag for developing some kind of compulsive overconsumption behavior. I think it's important to recognize that addiction is the final common pathway for all reinforcing drugs and behaviors. Alcohol works through our endogenous opioid system and our endogenous GABA system, which is our calming neurotransmitter. But at the end of that pathway, alcohol releases dopamine in the reward circuit, the nucleus accumbens, the ventral tegmental, and the prefrontal cortex. Same with cocaine, same with nicotine, same with caffeine, same with behaviors, right? Like pornography, gambling, shopping, food, right? Which is sort of somewhere between a behavior and a substance. So it's all the final common pathway is dopamine, even though they work through those different mechanisms. L-dopa, or the precursor in Parkinson's, it's interesting because it's like a hammer that's immediately hitting that buzzer that's going up to the top, right? There's no other work that has to be done. It goes into the brain to target the substantia nigra to relieve the movement disorder symptoms. But because it's not specific to that region, it's also targeting the reward pathway. And it's doing it pretty directly by directly binding to those postsynaptic receptors in that circuit, but which the body just sees as, oh, that's a really stimulating substance or behavior. It doesn't recognize it as, a chemical precursor. So truth telling, it works on a lot of different levels in terms of targeting addictive behavior. The first is that it makes us accountable to ourselves and others, because when we're engaging in sort of secretive, compulsive, consumptive behaviors, it's really easy to sort of let it stay in this sort of dark, unconscious recesses of our mind. But once we tell another human being, it brings it into relief and allows not just them to see it, but us to see it in a more granular way, or really maybe even at all. So it's really important that we're honest, not just with other people, but also with ourselves, around how we're spending our time and what we're actually consuming. The other thing is that, remember, the reward circuit involves the prefrontal cortex, and the prefrontal cortex is our storytelling and delayed gratification part of the brain. And even like a single dose of a dopamine precursor used to treat Parkinson's has been shown to decrease delayed gratification, or a person's ability to wait for their reward rather than having the reward right away. So it seems to be some kind of dysfunction actually in the prefrontal cortex as part of that reward circuitry. So truth telling can probably help to stimulate and upregulate the prefrontal cortex. There's an interesting study where individuals were involved in a die rolling task where they had to predict what the die would show. And if they got the correct predicted answer that was generated on a computer screen, they would win money. And what they found is that, most people lied a little bit, because the average adult tells 1 to 2 lies per day, usually small kind of lies that don't seem significant, but we're all kind of liars. And then they exposed those individuals to transcranial magnetic stimulation to stimulate the prefrontal cortical area. And they found that right after that, they were less likely to lie in that die rolling task, which suggests that there's a strong relationship, or a relationship anyway, between truth telling and how upregulated and online your prefrontal cortex is. So the idea is that by actively trying to tell the truth, we might in fact be stimulating our prefrontal cortex, which will then help us manage the kind of deep limbic structures that are driving this compulsive overconsumption. And then another way that truth telling works is that, it really helps foster trust and intimacy. One of the things that really breaks down an addiction is that our loved ones feel they can't trust us anymore because we've lied so much. So it takes a long time to build that up again. And so starting with being honest, even if it's, shameful and hard, and you have to admit having done something that you promised you wouldn't do, it's still better than lying. And typically helps, again, foster more intimate relationships, which is also a source of dopamine. So that, I think your assessment is right on. And probably there's a larger group that's in your category than not, is my guess. I don't think anybody has systematically explored that, which is to say it's not probably either or, like I didn't have any addiction problems and then I took L-Dopa and now I have a problem. It's a range, right? And we're all somewhere on that addiction range. And some of us are innately more vulnerable to the problem of compulsive overconsumption or addiction than others. And here I'm using impulse control and addiction sort of similarly, just to clarify the language. So I think it makes a ton of sense that in an area where you were already vulnerable, that your dopamine or Parkinson's disease, it's very clear that L-Dopa binds these reward circuits, binds the prefrontal cortex, the nucleus accumbens, and makes this kind of addictive vortex, more likely. And when we look at the risk of addiction across the board, we can basically put the risks into 3 major buckets: nature, nurture, and neighborhood. Nature has to do with whether or not you have a biological parent or grandparent with addiction. If you do, you're at increased risk to develop your addiction yourself compared to the general population, even if you're not raised in an addictive environment. Also, things like co-occurring mental health disorders increase the risk of addiction. And that's, again, probably a biological stepping stone phenomenon. Then you've got nurture. Those risks have to do with early childhood development, trauma, whether you were in an environment where people modeled addictive use as a coping strategy and condoned early use in your home. If that's true, then those are risk factors for addiction. And then finally, neighborhood has to do with access, and the way that simply having access to reinforcing drugs and behaviors makes you more likely to try it, which makes it more likely that that drug will then change your brain, which is, what addiction is. It is this brain change. What's interesting about Parkinson's and this development of these addictions is that it looks like they're mostly reversible when you take the brain away, which is kind of curious because you would almost think that, you develop those circuits and then they would be, not reversible. But it looks like most of the time, unless, you're someone like the person who commented who already had a pre-existing vulnerability, in which case maybe even if you took the meds away, you might still have the addictive disorder. Well, I think, any kind of brain damage, if it impinges on a specific circuit or nucleus, has the potential to cause a whole bunch of different types of mental disorders. I'm not aware of like a specific literature showing that this, type of brain damage, unless it's specifically in that reward circuit, is going to be closely linked to addiction. But then again, any type of brain damage is associated with trauma, and trauma will increase the risk of addiction. Well, the big challenge with opioids, as with all addictive substances, is the phenomenon of neuroadaptation that we've been talking about, which is to say the drug could work very, very well initially, but over time, as the brain adapts to it, basically stops working and then can even turn on that person and do the opposite of what was intended. And the overwhelming evidence shows that that's true for opioids in the treatment of pain. So there's good evidence to support their use short term, but the longer we take them and the higher the dose, the more likely they are to stop working, the more likely we are to need a higher dose over time, and the more likely they are to cause significant problems like addiction, like accidental overdose, hormone dysregulation, and increased pain through this phenomenon called opioid-induced hyperalgesia, or actually increased sensitivity to pain, not just in the original source of the pain, but in other parts of the body where the patient didn't have pain before. So that's why we generally don't recommend opioids to be taken long-term for the treatment of chronic pain. Yeah, so this is, again, the science of hormesis, or using toxic or noxious or painful stimuli in order to benefit ourselves. And there's a really strong evidence in both animal and human literature showing that ice cold freezing temperatures can be helpful for a myriad of conditions, from chronic pain to mood problems. And the way it works, again, is through the science of hormesis. Basically, it's a signal to the body that there's a potential injury. The body, in response, starts to upregulate its own endogenous production or internal production of feel-good neurotransmitters and hormones like dopamine, which, again, the neurotransmitter itself is indiscriminate. So if you're upregulating dopamine in the reward pathway, you're potentially upregulating it in your substantia nigra or your Parkinson's afflicted area as well. So such that ice cold water could be, a potential treatment to increase brain dopamine. And what the studies show is that when we immerse ourselves in ice cold water, gradually over the course of the latter half of that immersion or exposure, dopamine levels start to go up. And interestingly, they remain elevated for hours afterwards before coming down to baseline. So what's really nice about that is that you don't get that dopamine deficit state or that kind of rebound that you get with a direct dopamine agonist, right? Because you're paying for your dopamine up front by exposing yourself to this painful stimulus. Exercise. I mean, it's interesting for me to hear, Mel, that exercise is one of the mainstays of Parkinson's treatment. It doesn't surprise me at all. And probably, again, that's the science of hormesis, that by doing exercise, actually exercise is immediately toxic to cells, but it's healthy and good for us because systemically what it does is it activates the body through hormesis to start upregulating our own dopamine production, which again is exactly what you need for Parkinson's. Then it works on, in two ways. It increases dopamine in the substantia nigra to help with movements, but it also increases dopamine in the reward pathway to help with mood and all of that. Well, I think, obviously, even people who have, an addictive shopping disorder or gambling or a loss of judgment or impulse control, as a result of their medicine, If they have to take the medicine, they can't go down on it because they're Parkinson's. Then you're living with an addiction. And I think it's kind of this paradox where, yes, it is a brain disease, and we frame it as a brain disease. And then we help individuals and families learn how to cope with that. And so, but it does mean that the agency of that individual or their ability to control their behaviors is limited by the brain disease, but it's not zero. Right. And so, in the level at which it has to work again is this sort of radical honesty, like maybe, someone with this problem because of their Parkinson's medication, maybe they can't control it all that well, but they can be honest about what they did. Or what I talk a lot about in the book, but also in my clinical practice for people with addiction, is something called self-binding strategies, where in acknowledging that with an addiction, I'm going to have a hard time controlling my impulse to ingest my drug once that drug is presented to me, I will acknowledge that and then essentially change my environment so that I can press the pause button between wanting that drug and actually ingesting it. So that's very simple things, but that can go a long way, like not keeping the drug in the house, not having access to certain internet sites, not having, money in my pocket. These are all self-binding strategies that we can use to help ourselves with our compulsivity and our impulsivity. There are even now credit cards that you can buy that specify what they can be spent on, that I have a lot of families using for their addicted loved one, because they know if their addicted loved one has a credit card in their pocket, it's going to be impossible for them to not spend. So the credit card then specifies what they can spend it on or what kinds of stores. These are all forms of self-binding that I can imagine would be very useful, even in the context of, a Parkinson's induced problem.
Yeah. I mean, it reminds me of a story that I always go back to. There was a couple, and the gentleman was very, very addicted to porn. And as a couple, they made the decision that that addiction was better than his mental state off of the medication. And so they came to an agreement where they said, okay, here it is. There are boundaries. You can do this here at this time, and this computer is available to you. And they made it work. And so I guess the important part for me here is to teach people who are going through this experience that there are strategies to help you. And if you are on a medication that is creating these, they're told all the time, they weren't told that this was going to happen. And it happens. And then they don't know what to do. And they're worried about going back to their doctor. Go back to your doctor. Say, this is not working. Yeah. This is a side effect that is not working for me. Is there something else that we can try? Yeah. So I think there's a lot of great takeaways. We're going to share the recording and the transcript and the show notes and lots of different links. And I hope you guys enjoyed the conversation. I really enjoyed talking to you. And I know Parkinson's is not your expertise, but impulse control disorders are a big thing for our community. And so I really appreciate being able to offer a little bit, because we really don't have a lot of resources for people who have this situation.
Oh, well, thank you. Thanks for having me. And thanks for everybody who showed up and for your questions. Sorry, I couldn't answer all of them. I wish I knew more about Parkinson's, but I hope this was helpful.
It absolutely was. Thank you so much.
Thank you for joining us for this episode of the Parkinson's Podcast. For more information about the Davis-Phinney Foundation and to learn about educational offerings and community events for people affected by Parkinson's, please visit davisfinneyfoundation.org or dpf.org.